Welcome to Module 203A on Principles of Automatic Heating and Cooling Circuits. Our last objective is to look at the legal requirements that we have according to code on the electrical installation of heating and cooling systems. The code requirements for heating and cooling systems are covered underneath multiple sections of the code book. We're going to focus on the rules for domestic systems in a dwelling unit. We start with Rule 2110, which tells us the maximum voltage to ground for our furnaces cannot exceed 150 volts. Which is good because that's the system voltage that we have for our houses anyway. Rule 26806 states that any heating equipment rated at 117 kilowatts and less, which is our typical gas-fired furnaces, must have its own separate branch circuit. It also says that any associated equipment can also be on that same circuit. So we would be talking about things such as humidifiers, electronic air filters, HRV units, and UV filters. Check out Appendix B on that rule. 26808 says that any electrical heating equipment rated at more than 117 kilowatts, which would be our electric heating, baseboard heating, and such things as that, they must all have their branch circuit and they're provided for only the heating equipment and their components. For any larger equipment, a suitable disconnect means is also required. Since my furnaces are typically mounted on a basement floor, I have to pay attention to Rule 26802, which speaks about the mechanical protection of conductors. My NMD90 is not armored, so therefore I cannot run it directly into the furnace. It will be below that 1.5 meter limitation. Instead, I'll do this section with an armored cable such as AC90 in order to protect my wires. I also need to go back to Rule 26806 and look at subrules 5, 6, and 7. These talk about the disconnecting means I would have for my typical furnace. Each furnace needs to have a disconnect. Subrule 6 tells me that can be a breaker if the breaker is between the entry point and the furnace. If the breaker is after the furnace, you need to have a separate disconnect switch. Keep in mind, it cannot be mounted to the furnace or the ductwork or anywhere where you need to pass the furnace to reach it, and it must be labeled to indicate what it controls. The reason for this is if your furnace is burning up, in order to kill your furnace, you don't want to have to go through the fire to get there. So make sure the separate switch is located somewhere where it's intelligent and it's easily accessible. When it comes to the disconnect switching for an AC unit, I have to make sure I pay attention to Rule 2326, electrical equipment near combustible gas equipment. So if you think about our gas meter on the side of our house, where we place the disconnect switch for my air conditioner is going to matter. We need to make sure that we look at Appendix B, which states that we must have a minimum of a 1 meter distance for natural gas relief valves or 3 meters if we're dealing with a propane gas system. So make sure you know what type of gas the house has and make sure that your AC disconnect is far enough away from that gas meter. It's not going to cause any problems. The location of disconnecting means for the air conditioning unit shall be located within sight and 3 meters of the equipment. Typically, when we're doing a rough-in, we want to make sure that we place the disconnect wires somewhere where the air conditioner is going to be. They're easily accessible. Nobody else can turn the air conditioner on or off while we're working on it, so you need to have it within sight. But also keep in mind, you don't want it directly behind the unit because then it might be difficult to access that disconnect. Since my furnace not only employs 120 volts, but it employs 24 volt circuits, we also have to be aware of the rules on Class 1 and Class 2 circuits. 16200 tells me about limitations of Class 2 circuit. Any Class 2 circuit is limited to 100 VA, which means if I have a 20 volt circuit, it can operate at not more than 5 amps. Normally, the transformer inside the furnace is 100 VA transformer, which does that limitation for me. When it comes to the conductors I can use for my Class 2 wiring, I need to make sure that they're properly approved according to Table 11. Typically, LVT cable is approved for use in Class 2 circuits, such as thermostat controls, doorbells, security systems, and other low voltage remote control systems, as long as we do not exceed 30 volts. Rule 16116 states that mechanical protection of remote controlled circuits must also be in place. It refers back to Rule 16110, which states that any remote control circuits that operate safety devices are deemed to be Class 1 circuits. So any remote control circuits in accordance with that rule need to be protected from mechanical damage, moisture, and corrosion. The type of things that we're talking about are wiring for the high limit switches, exhaust interlocks, boiler low water cutoffs, or high pressure switches. All these are safety switches and they will need to be installed in either a conduit or a flex to provide that mechanical protection. When it comes to separation of class 2 circuit conductors, we need to make sure that we have some sort of separation so there's no magnetic interference or any possibility of applying the wrong voltage to the wrong circuit. And since we have multiple types of circuits in heating equipment, we also need to make sure that they are adequately separated. Subrule 3 states that we cannot mix class 2 circuits with any other circuits, and Subrule 4 states that the only time we can have a class 2 circuit in the same enclosure as a class 1 or power circuit is if it is for the purpose of supplying power to the class 2 circuit. So in this case, it would be for a transformer. If we had a transformer inside an enclosure, then that's the only reason we can do that. Our wiring methods will depend on the equipment that we need to install in order to avoid these types of conflicts. You've now reached the end of Module 203A. Make sure you're going back through your knowledge, paying special attention to any of the terminologies, the parts of a furnace that you need to know, any drawing symbologies that are on both the schematic and the wiring diagram, and know the difference between them. You can then return to Blackboard, do the knowledge check, and continue on to 203B.